Section 3.2 is a very long section, so if you want to do it in parts, I would recommend you do about 15 minutes, take a break, and then come back because this video is going to be a longer one than you're used to. So we're talking about the quadratic functions, and you are used to it in its parent form, f of x is equal to x squared. There is a standard form that you've seen in Algebra 1 and Algebra 2. This is the one that you probably have used the most. And now we get to add in a vertex form. Now, regardless which way it's written, okay, whether it be standard form or vertex form, both of them have the same thing in them in that you have an a value here. So the a value is very important because if the parabola opens up, that means that a is positive. And if it opens downward, that means that a is negative. So you have to keep track of that. Okay. Additionally, you have these vertical lines that the vertex is on. This is a vertex that we will call HK. And depending on which way this opens, the vertex can be a maximum, as in this one, absolute max, or it can be an absolute minimum. You also have this axis of symmetry. And it does exactly what it says it does. It cuts it in half. Okay, I'm going to abbreviate over here, axis of symmetry. And from here, you're going to be going into the actual graphing of it and putting it from one form to the next. So in this first example, we have the equation y is equal to negative 2x squared plus 14x minus 14, and it wants to know these things to the right. So it's going to ask for a vertex. It's going to ask for a vertical intercept, which means that it wants to know where the y-intercept is, and then it's also going to want to know what your x-intercepts are. So we, for this one, are going to use the vertex formula. There's two different ways to do this, and later we're going to have to do it the other way because the question specifically tells you to. But for us, the vertex formula is going to be h is equal to negative b divided by 2a, and then k is going to be whatever you get evaluated in the function that you started with. So in ours, we have a is negative 2, b is positive 14, and c is negative 14. So h is equal to negative 14, and then I have 2 times negative 2. So I have h is equal to 14 over 4, because the negatives cancel. So that's going to reduce to an h value of 7 halves. So then we come up and we find out what k is. So to do k, I do f of 7 halves, which means I'm going to plug 7 halves in everywhere I see an x. So I have 2 times 7 halves squared plus 14 times 7 halves. And then I'm going to lastly subtract 14. So this gives me a negative 2 stays. This is 49 over 4. This 2 goes into 14 7 times. So 7 times 7 is 49. And then I still have the subtraction of 14. 2 goes into 4 twice. So this one is going to give me negative 49 halves plus 98 halves minus 28 halves. All I did there was get a common denominator. Then we're able to subtract or add. So we have negative 49 plus 48, and then I subtract 28. So this is going to give me 22 over 2. Which gives me the number 11. So the vertex up here is going to be the ordered pair point HK, which is 7 halves 11. All right, then we're going to start from scratch. We're going to find the y-intercept. In order to find the y-intercept of this equation, we're going to let the x's be equal to 0 and solve for y. So y is equal to negative 2 times 0 squared plus 14 times 0, and that's subtracting 14 from it, so y is equal to negative 14. So then your y-intercept is at an x value of 0 and a y value of negative 14. And then we're going to start all over again in order to find your x-intercepts. So to find the x-intercepts, we let y be equal to 0 and solve for x. So we have negative 2x squared plus 14x minus 14 is equal to 0. And I have a GCF of -2, so I'm going to divide everywhere by -2 to make my life a little easier. And in doing so, I've done two things. Number one, I have made my leading coefficient positive, because that turns into x squared. And then I've made all of my other numbers a little smaller. So I have -7x plus 7 is equal to 0. Now, at this point, we try to use factoring in order to solve this, but I know there are no factors of 7 that add up to give me a -7. So at this point, I'm going to refresh your memory over here. You have the quadratic formula. So you're going to have -b plus or minus, x is equal to, rather, excuse me. -b plus or minus the square root of b squared minus 4ac, and then you're going to divide that by 2a. And this is where your imaginary numbers can sometimes come in, and that's why we had to do that prior to this. All right, so now I know that my a value is 1, my b value is -7, and my c value is +7. So I have x is equal to a negative b, so that becomes +7, plus or minus the square root. Now b squared is -7 squared, which is 49, minus 4, and then I'm going to go ahead and multiply a times c. That's going to give me the number 7. And then under here we have 2 times a, which will give us a 2. So I have 7 plus or minus square root of 49 minus 28. And we're going to divide that by 2. So then we're working under that radical. We have 7 plus or minus 49 minus 28 gives us 21. So we have the square root of 21 over 2. And because the square root of 21 will not reduce in any way, those are my two answers. So when you type these in, you're going to have to do 7 plus the square root of 21 over 2 is one of the answers. The other answer is 7 minus the square root of 21 over 2. If it wants it as ordered pairs, obviously you would have two different ordered pairs. Your y values would be 0. When a question asks you to put a standard form quadratic equation into the vertex form, you have two different ways to do it. I'm going to do this first one using the vertex formula that we used a minute ago. So I have h is equal to -b over 2a. And then I know that k is equal to f of h. And the only other thing that you have to do if you use this pattern is to decide from your given equation what a is. So in our case, a is equal to 1 because there is nothing written, so it's understood. So I'm going to do h is equal to -b, which is negative, and then I have b is 8. And then I do 2 times 1, which is 2, so my h value is -4. And then I come up here and I do k is equal to f of 4. So I plug that in. So k is equal to 4 squared plus 8 times 4 plus 7. That's going to give me 16 plus 32 plus 7. 16 and 32 gives me 48 plus 7 gives me 55. Now, how we do this is to come over here to the y equals. So this is y equals. Technically, there's an a right there, but because this one was a 1, they left it out because you do not type that. So there is a 1 there. We are not writing it or typing it. So I have x minus h. So x subtracting a -4 becomes 8x plus 4 quantity squared. And then my k value is a 55. So that would be my vertex form for the given quadratic function. Now, on the next one, I'm going to do it the other way, okay? So this one, we are going to put it in vertex form using completing the square. And you do have a homework question that says, by completing the square. So you will have to at least do this once on your homework. If on the quiz or test it doesn't tell you to use this method, then you can use the method above. So with this method, what you do is take the first two terms together, kind of group them together and leave a spot right here. And then whatever this constant is gets bumped out to the side. That's your first step. Now, at this stage, you want your a to be a 1. Ours is, so there's a step we get to omit that I'm going to do in the next question. So at this point, I want to actually complete the square. So in order to complete the square, you take whatever your b value is, you divide it by 2. So my b value will be this negative 14 right here. So I pull that over and go negative 14 divided by 2, so that gives me the number negative 7. I'm going to circle that because I'm going to need it in just a minute. So then I square that number, and that's going to give me the number that goes in my line. So this is adding 49 right here. And because I am staying on the exact same side of the equation, I have to keep it balanced. So I have to subtract 49. So by me doing this, where I add 49 here and I'm subtracting 49 here, I didn't actually change the value on that side. It's very important to make sure that you keep it balanced. So this is going to give me y equals, and now I'm ready to factor this. And in order to factor this, I just need the variable that I started with, and then I need this circled number right here. So this is x minus 7 quantity squared. And the last thing that I need to do is just combine these two. So 48 minus 49 is negative 1. If at this point it asks you what your vertex is, you can very clearly see that this is x minus h quantity squared plus k. So we have it in vertex form. So my vertex is, of course, hk. My h is the number 7. My k is the number negative 1. So that would be my vertex if it asks for that. So when your leading coefficient is 1, completing the square is a little less complicated. It's not that it's impossible if you don't have a leading coefficient of 1, so we're going to do one of these. So this one does say by completing the square, so we have f of x is equal to, again, you're going to take these first two terms and you are going to group them together, leaving a little space, and then you bump out the negative 79. Now, in this equation, I do not have an a of 1. So what has to happen is I have to take this number and make it into a 1 by factoring. So I'm going to be factoring out a negative 3. So when I do that, I actually factor out a negative 3 here. So divide by negative 3, and you divide by negative 3 here. So this is going to give me x squared minus 10x. And then I still have my line. I still have my negative 79. And from the last one, I know that I'm going to have to do something out here as well. We are still staying on the same side of the equation. So what I'm going to do at this point is rewrite this. And then I know that I have to complete this square. I'm going to come over to the right-hand side and do that. So I'm still going to take b and divide it by 2. My b is the number negative 10. You have to be careful with your signs here. So I have negative 10 divided by 2, so that gives me a negative 5. And that's the number that I'm going to circle because I use it as I factor. So then I square that, and I get the number 25, and I'm going to underline that. Now the reason I'm circling and underlining is this underline is equivalent to this right here. So that's where that number goes. So I'm going to add 25 right here. But notice that I have two lines over here. When I have a number that I have had to factor out, like this, I didn't actually add 25. I added 25 on the inside, but what I really did was negative 3 times 25, which gives me negative 75. So when I put that red 25 in there, I have actually subtracted 75. So now to keep it balanced, I have to add 75. Again, keeping it balanced. So at this point, I'm ready to factor. I take the x, that is the variable that I'm starting with. I take my circled number and I square that quantity. Then I have negative 79 plus 75, and I combine those two and get negative 4. So again, if this one asks me what my vertex is, I have hk. H is the number 5, and k would be negative 4. Another question that they're going to ask you is to give you a partial equation. All right, so we know that a is 3 here. It wants us to find b and c, so the coefficient on x and then your constant term, so that it has a vertex of 3, negative 1. So this is h and k. So to do this, we are going to use h is equal to negative b over 2a, and then we're going to use f of h is going to be equal to excuse me, K is equal to f of h. All right, so I'm given the h value of 3. It tells me that my vertex is located at 3, -1, so instead of h, I'm substituting in that 3. Now, I do not know what b is, so the negative b has to stay. And I do know what a is. A is the number 3 given in this original equation up here. So this gives me 3 is equal to negative b over 6. So negative b then is equal to 18. So b is going to be the number 18. Now, if I know that b is 18, then I can plug it in right here. B is 18. Plug that in there. That's what b is. We just found that one. All right. And now I need to go find, using k, I have to go find c. So my k value is -1. And then I'm doing f of h. Well, my h ended up being, or I know rather, that it is the number 3. H is 3 from right here. So if I do f of 3, I have 3 in the given a value. Then I do 3 squared plus 18 times 3 plus c. And I'm going to solve this for c. So I have -1 is equal to 3 times 9 gives me 27. 18 times 3 is 54 plus c. So I have 27 and 54 give me 81. And when I subtract 81, we get a c value of -82. So those would be the two answers that you would plug in.
You're doing better than I am.
This should have been a -4. That's a -4, which makes this a -32, which creates a different number here. -32, so that's -16 plus 7, that's -9. So this out here will be a negative.
But this is a bird though.
Writing an equation from a graph, it works a little bit easier now because we are going to use y is equal to a parenthesis x minus h quantity squared plus k. Because I know that that point is 1, 4, and I also know that that is hk. I know that a has to be a negative number because this thing goes down. So I have y is equal to a, I still have to go find, x minus 1, quantity squared, plus 4. And at this point, I just have to choose another ordered pair point in order to figure out what a is. And this is what we were doing in the last chapter, so this should not be complicated for you, hopefully. All right, I'm going to use the ordered pair point 3, 0, or you could use the ordered pair point 2, 3. You're going to get the same answer regardless which one you use, okay? So I'm going to use 2, 3. So 3 is equal to a, and then I have 2 minus 1 quantity squared plus 4. So I have 2 minus 1 is 1. 1 squared is 1, so this is a plus 4. So then a is equal to -1. So the equation would be y is equal to a negative. You can put the 1 or not, that's up to you. And then I have quantity x minus 1 squared plus 4. The next one is giving us an equation to start with, and I have a vertex, domain, and range. So for the vertex, you can use either completing the square or you can use the vertex formula. I know most of you all prefer the vertex formula, so that's the one I'm going to use. I have h is equal to -b over 2a. So I have a positive 28, because when I substitute in a negative makes it positive. And then I have 2 times -7 is -14. So then h is equal to -2. Then k is equal to f of -2. So as I plug this in, I'm going to scoot over just a little. I have -7 times 4 minus 28 times -2 plus 7. So we end up with k is equal to -28 plus 56 plus 7. Well, 56 minus 28 is 28, and 28 plus 7 gives me 35. So my H and K is at negative 2, 35, and that is an ordered pair point. Now, the rest of this problem is fairly straightforward because we know that this is a parabola, and because this A is negative, I know that this graph would look something like this. This ordered pair point is at negative 2, 35. So as we look at the domain of this, it's everything because it has no restrictions. And when I look at the range, of course, I'm going from bottom to top. Well, the bottom never stops. So it goes from negative infinity, and it goes up to the highest y value because this is my maximum, and it will include the number 35. Make sure you look at the y values, not the x values. This problem is copied from your homework, and the first thing it wants to know is whether it has a minimum or a maximum. So this one, of course, is going to have a maximum. The maximum of is your y value, so that's 0.25, at x equals 5.5. Then it says it's increasing on what interval. So again, we know that we're riding that roller coaster, so it increases from negative infinity up to, but not including 5.5. And it is decreasing, of course, on the other side of that maximum. So this goes not including 5.5 to infinity. The domain for a quadratic is all real numbers. And then the range, you read bottom to top. So these keep going to the bottom forever, so negative infinity, and it goes up to and then includes the y value at 0.25. We include it because it's talking about not increasing and decreasing, but what the range is. The next question is a little bit of a refresher from 3.1, and it's showing you what's going to be happening from what goes on from now on. So the first thing we're going to do is separate 108 and then the square root of negative 1. So 108 is divisible by 36, so that's 36 times 3. And then that whole thing is divided by 9. So we have the negative 9, and then we're going to subtract. So we have the square root of 36 is the number 6. The square root of 3 stays the square root of 3. And then we have I for the square root of negative 1. So I'm going to put this over 9, and I'm going to put this over 9, and then we reduce those fractions. So negative 9 divided by 9 is negative 1, and then 6 over 9 reduces to 2/3. And then we still have the square root of 3, and this, of course, is an imaginary number. Now, that leads us into using the quadratic formula. So if you don't remember it, go ahead and pause the video and write this down, because now we're going to use these to solve quadratics that are not factorable. The quadratic formula is not just for when they don't factor. You can use it anytime you want, but this one is always going to work. And if it's not factorable, this is what you have to revert to. So we know that my A value right here is 1. We know that the B value is negative 2. And then C, of course, is your constant, and that gives me 20. So you could try to factor this. It's not going to factor. So we have that P instead of X, because that's the variable I have, is equal to negative B, so that's a positive 2, plus or minus. And then we have a big radical. And I'm going to go ahead and take B and square it. So negative 2 times negative 2 gives me 4, minus, and then 4 is part of my equation. And now I'm going to multiply A times C before I plug it in. So that gives me 20. And then in the bottom you do 2 times A, so that gives me 2. So now we're at the point where we were in the question above this, where you're just going to be simplifying. So we have 2 plus or minus. I still have the square root of 4 minus 80. And that whole thing is divided by 2. So we end up with 2 plus or minus the square root of negative 76 divided by 2. Now this tells us a couple things. These two roots are both going to be imaginary. This also tells me that this quadratic does not intersect the x-axis. So there are no real solutions, which means there's no x-intercepts. It does not cross the x-axis. That's important because what we're going to be doing in the next couple sections. So be careful to understand that if it's imaginary, then they do not intersect the x-axis. So at that point, we're looking at 76, and we're trying to see if that will reduce in any way. You also have to make sure that you take the negative out. So the square root of 76 changes into 4 times 19 times the square root of -1, and that's divisible by 2. And then we have 2 plus or minus 2 square roots of 19i. We divide this by 2, and we divide this by 2, and reduce both of those fractions. So I'm going to do this off to the side. 2 divided by 2 is 1, and then we have plus and minus, and then 2 again divides by 2 get to give me 1, so I have the square root of 19i. So as you type these in online, you'd have to do 1 plus the square root of 19i, comma, 1 minus the square root of 19i. So you have to be careful not to put that I under the radical, because that would count it wrong. Some students prefer to write it in front of the radical, so you could put it here and not have it back here. I do not care which one you use. Typically, we use that A plus BI format, so the B should be in front of it, but I'll leave it up to you to make that decision. With the next question, we can try to factor, but it will not work. So again, we're going to use our quadratic formula. We have x is equal to negative b plus or minus the square root of 196 minus 4 times 1 times 58, which gives me 58, and then we're dividing that whole thing by 2. So now we're down to the simplification process. We have negative 14 plus and minus. We have 196 minus 4 times 58 is going to give us a total of negative 36, and that whole thing is divided by 2. So we have the radical we have to deal with. We have negative 14 plus and minus square root of 36 times the square root of -1, and that's divided by 2. So from here, we're going to have x is equal to negative 14 plus and minus 6i, and then we're going to divide this by 2 and divide this by 2 and reduce your fractions. So keep up to the right. So I have negative 7 plus and minus 3i. So those would be my two solutions for this one. Next one, we can try to factor this, and it absolutely will not factor, so we're going to be doing the exact same process. So we have x is equal to negative b plus or minus the square root of, when I square b, I get 144 minus 4, and then 1 times 45 is 45. And we divide this by 2 times a, which is 2. So we have x is equal to plus and minus the square root of 144 minus 180, and we divide this by 2. So we have 12 plus and minus square root, negative 36 again, divided by 2. So x is equal to 12 plus and minus the square root of 36 times the square root of -1, and then we divide that by 2. And then we have 12 plus and minus 6i. We divide this one by 2 and this one by 2. And to the right, we would have a solution set of 6 plus and minus 3i. This one starts off looking a little bit different, and it absolutely is imperative that you have this equal to 0. So the first thing we're going to do is subtract the 5 over. So this will turn into a 4 right here. So this would become a 4, and this would become the 0 that we need it to be. So again, I can try to factor this. I would slide and divide, or using 4 times 4 to 16, but there is nothing that multiplies together to give you 16 and adds to 3. So we use our quadratic formula. So m is equal to negative b plus or minus. We have b squared is 9 minus, the 4 is already part of the equation, and then I multiply a times c, so that gives me 16. And then we are dividing that by 2 times a, which is 2 times 4, which is 8. So we have negative 3 plus or minus the square root of 9 minus 64. And we're dividing that by 8. So m is equal to negative 3 plus or minus the square root of 55. over 8. And the square root of 55 will not simplify or reduce in any way, so you can write it like this. If it wants it separated, it would be negative 3/8 plus or minus the square root of 55 over 8. I don't think it's that picky online. The next couple of questions are word problems that are going to take us a couple minutes. So this is one of those places where if you need a break, I would go ahead and take it now. But once you come back, you'll start here. So this is giving us an equation of negative 4.9 t squared plus 1300 t plus 190. So from our previous experience, we know that this rocket will do this. Now the difference is that your y-intercept is up at 190. So this would be your x-axis, this would be your y-axis, and technically speaking, this part of your graph wouldn't be there. So none of this is included. And the first question is asking us from what height was the rocket launched? So to answer this question, it would be right here, which would be our h-intercept. All right, what's the maximum height it reaches? So that would be part of h and k, okay? So the height itself is going to be the y value. The h would be what time that occurred, but the k is going to be the actual answer to how tall it gets. So it would be the t coordinate, the h. Okay, I see where this is going to be a problem. So our equation is h of t is equal to the equation that they give you. So with respect to this, the t is on your x-axis. Okay, so we're going to erase the h. And the h is on your y, which is confusing. So instead of hk, we are going to have th are the coordinates of every ordered pair point. So we want to find the h coordinate of the vertex for that answer. If the rocket will splash down in the ocean, when will t splash down? So here's splashdown, and that would be the t-intercept. So understanding what it's asking for is important, and that's the sole purpose of this question. You're not actually working anything out. So the next question is actually talking about a rocket that's launched at the given equation, gives us the function as far as what it's actually doing as the height with respect to time. So assuming it will splash down in the ocean, at what time does, and it's asking you these couple of questions. So again, with this equation, you are going to be looking for those things that we looked at in the last one. So splashdown is going to be our t-intercept. So if we have y is equal to negative 4.9 t squared plus 190 t plus 325, and we want to find a t-intercept, changing my y to an h for the height, then to find a t-intercept, I let y be equal to 0, and in our case h. So this is equal to negative 4.9 t squared plus 190 t plus 325. And I'm not going to try to factor that because it does not factor very nicely. So we are going to use the quadratic formula. So I have t is equal to negative b plus or minus the square root of. Then we have b squared, which gives us 36,100 minus 4. And then when you multiply a times c, you end up with negative 1592.5. And we are dividing that entire thing by 2 times a, which is negative 9.8. So then we're just cleaning this up a little bit. We end up with negative 190 plus or minus, and we have the square root, and I'm going to go ahead and do that entire calculation underneath there, giving us 42,470 under that radical. And then that whole thing is divided by negative 9.8. And at this point, obviously, there's going to be decimals that go along with this. So we're just gonna do the final answer, go through and do all these individual calculations, and you'll end up with negative 1.641072219, and the other answer is equal to 40.41658.242. And obviously we're talking about time, so this one must be disregarded. So this rocket will reach its splashdown at 40.41 seconds after it takes off. So for the next part, we are going to be using, of course, that exact same equation. So we have the height is equal to negative 4.9 t squared plus 190 t plus 325. And the other question in this problem is asking us how high does it reach at its peak. So another way to say that is the y value of the vertex. So for us, y value of the vertex, which typically is the ordered pair point HK. And for us, of course, it changes into TH. So we just need to find the vertex point. So I'm going to use the vertex formula. So the T value is equal to negative B over 2A. So this is equal to negative 190 divided by negative 9.8. which gives us a time of 19.3877551. So that's how long it takes to reach its peak, which is approximately halfway from the splashdown. And then to find the actual maximum height, you'll do h of that time. So 19.3877551. And when I do that, I end up with, and you got to be careful not to lose your decimal points on this, because you have to square that number, and then I'm going to slide it over a little. So we add 190 times that same decimal, so 19.3877551, and then we're going to add 325 to that. This results in a maximum height at its vertex of 2,166.836735 feet. This next question is talking about a ball that's thrown by a child. So you have a little bit different looking equation. You've got y is equal to negative 1/16 x squared plus 2x plus 5. Now it still has the exact same pattern of information. So it's going to be launched, it's going to go up, and then it's going to come back down. So this height is the first thing it asks. How high is the ball when the child leaves the child's hand? So that's just going to be this y-intercept, which occurs at 0.5. So that would be 5 feet in the air when it is launched out of the child's hands. So what's the maximum height of the ball? So we're taking and finding our vertex. So we have h is equal to negative b over 2 times a, so that's negative 2 times negative 1/16. So this is going to give me a negative 2 divided by negative 1/8. So the negatives cancel, and this gives me 16. So it has an x coordinate. Those shouldn't be h's, I'm sorry. Those are t's. Sorry about that. The time it takes to get to its maximum height is 16 seconds. And then we will have the function y of t. So y, or the height of the ball, is going to be negative 16 times 16 squared plus 2 times 16 plus 5. As we go through and work this out using order of operations, you get 256. So obviously this is going to cancel into that and be 16. So this is negative 16 plus 32 plus 5. So this is going to give me 16 plus 5, which gives me a maximum height of 21 feet. How far from the child does the ball strike the ground? All right, we haven't had one of these yet. So this is asking for this x-intercept over here. So we use that exact same equation and we find out where the x-intercept is. So I'm going to do this up underneath. So we have negative 1/16 x squared plus 2x plus 5. And we're trying to figure out when it has a height of 0. So again, I'm not going to try to factor this. It's probably not going to factor. So we have x is equal to negative b plus or minus the square root of. And then we have b squared, which is 4, and then minus 4. And then a times c is negative 5/16. And we're going to divide that by 2 times negative 1/16, which is negative 1/8. So we have to clean up underneath the radical. So the 4 goes into 16 4 times. So I have 4 minus 5/4, plus 5/4. So this is going to be 20/4. Nope. 16/4 plus 5/4. So that's going to give me 21/4 under the radical. So I have a negative 2 plus a minus the square root of 21/4. And I'm going to divide that by negative 1/8. So these are usually going to let us allow decimal values. So I'm going to change all of this into decimals. So I have negative 2 plus or minus, and then the radical turns into 2.291287847. And I'm going to be multiplying that by negative 8. So that answer times negative 8, because I'm going to keep it, flip it, change it. So if you all want to change that into the fractional version, whichever way you want to do it. So again, I'm talking about I'm calling it an x-intercept. It's actually a t-intercept. But in order to have that, you're going to have a positive t, because obviously our time can't be negative. So since I'm dividing by a negative, I need the top to also be negative. So I have negative 2 minus 2.291287847. And I'm going to multiply that by negative 8, which gives me a final answer of 34.33030278. The next question is talking about a box with a square base. So I draw the 3-dimensional of this just so kids can see it. So you've got this scenario, and the base that's at the bottom, you can't actually see it in this diagram, but what it's doing is making a square. So you've got to imagine that this would be, if I flipped it upside down, this would be the base, okay? So this is going to be a square. So I'm going to draw that square right here. So this is that base that it sits on. And it says that we are going to take that and we're going to cut corners of 4 inches squared from each of those corners. So I'm going to make this very large. Okay, so we are going to take this and cut 4 inches square. We're going to take this and cut 4 inches square. We're going to cut this and cut 4 inches squared. And of course the last one as well. So 4 inches squared all the way around. Now, if this big bold length from here to here is x, and that's the same on all 4 sides because it is a square base, then if I look at the fact that this is now gone and this is now gone, well, those are the same length as this. So the new size of the box, after that cut out of those corners, is x minus 8, because I subtracted 4 on one side, 4 on the other. All right, so then that's the case here as well. The length from there to there is x minus 8. And of course, it's going to do that all the way around because it is, in fact, a square base. Now, what that means is if I drew this box back the way it was before, so I've got, this is the front, this goes back this way, and then I've got this. then this length right here is x minus 8, and this length right here would be x minus 8. And then the height is going to end up being how tall this is after I cut that out. So that height is 4. If you need help understanding what I'm doing right here, and if I've lost you, then just come see me. Otherwise, we know that we are trying to create a volume with this. So volume is length times width times height. So my volume is the length, which is x minus 8, the width, which is also x minus 8, and then the height, which is 4. In the problem, it said that we want our volume to be able to hold 784 cubic inches. So I have this equation, and we're going to solve this for x, which is going to tell me how big my original box had to be. So the first thing I'm going to do is divide 784 by 4, so that gives me 196. Then I end up boxing or foiling the left-hand side, or excuse me, the right-hand side. So we end up with this expression. Once I take 64 and subtract 196 from it, we end up with x squared minus 16x plus 132, minus 132. And that's equal to 0. So we now have to use quadratic formula to solve this because I don't think it's going to factor. So we have x is equal to negative b plus or minus the square root. When we take 16 and square it, we get 256 minus 4. And then we're multiplying that a times c, which is negative 132. And that whole thing is divided by 2 times a, which is 2. So this gives me 16 plus or minus. Working under my radical, we end up with 784, and we're going to divide that by 2. And again, at this point, we're going to be changing over to the decimal versions of these. So the square root of 784 ends up working out nicely. I didn't remember that one, so that's 28. And divided by 2, so x is either equal to 16 plus 28 over 2, or it's going to be 16 minus 28 over 2. Now, if this was a pure question that was just algebraic, then both answers would be considered. In our case, however, I can't take the negative one because I'm talking about a side length. So when I do 16 and 28, we end up with 44, and 44 divided by 2 is 22. So the original dimensions have to be 22 inches by 22 inches. And I know that they're the same because they said that it was a square. The next one is talking about building a pen. So I'm going to walk us through this. Here is my barn, and what he is going to do as he makes this fence is to make sure that we use the barn as one of the sides, and that way I can use more of the fencing in order to make a bigger area. So I have to go, it says rectangular, so I'm just going to generically draw a figure out here and say that this is going to be my pen. All right, and even though it doesn't look like it, we're going to pretend like that's even all the way around. Sorry about that. So we have a width, we have another width, and we have a length. And it's very important that you understand that there are not 2 lengths, because this barn is already providing one of the sides. I don't need fencing along that side. So I have 2 different equations I got to use. I have perimeter would be W plus L, which simplifies down to 2W plus L. And then the other one I'm talking about is area. So I know that the area of a rectangular polygon is length times width. So what we're going to be doing is looking at, let W be the length of the pen perpendicular to the barn. All right, so we are actually calling that W, just like they told us to. It says to write an equation to model the area of the pen so that it's in terms of W. All right, so this says that we have 700 feet of fencing to use. So that's how much of a perimeter I'm going to have. So I have 2W plus L. And what we're going to do is, because we want it in terms of W, that means W has to be in my equation that I create. So I'm going to take this equation and I'm going to solve for L. So L is going to be equal to 700 minus 2W. And now what we're going to do is take 700 minus 2W and we are gonna plug it in where L is. So my area then is gonna be 700 minus 2W, and I'm gonna multiply by W, so that the area in terms of W is equal to negative 2W squared plus 700W. This equation is what goes right here. This wants an equation. This is not a number answer. It wants you to write it so that it's in terms of W. And now we want to maximize this height, or excuse me, maximize this area. So if I want to find the maximum of this, well, I see that it's quadratic and it has a negative leading coefficient, so it does this. So what we're looking for is our vertex point. So again, we want to know what width would maximize the area. So I need to know what my vertex point is. All right, so in general, this is HK. For us, using the variables that we have, this is going to be WA of W. So that's the order of pair points we're wanting. So our quadratic formula says that we use H is equal to negative B over 2A. For us, it's going to be W is equal to negative B over 2 times A. So we're going to have 700 divided by 4. And this is going to give us an answer of 175. Now, what that means is if I created my rectangular section, I would have 175 against the barn on both sides. And then if it wanted to know what the rest of it was, you could go find that. This question only wants to know what width will maximize area, so that would be your answer. Should you be asked any other question on this, all you have to do is plug that in. So if I had the area when my width is 175, that's going to give you what your maximized area is. So we simply plug this in, which is identically the same as finding the K value or the A of W value. So you would just plug your 175 in, and this is going to tell us that we have 175 squared is 175 squared, very large number, times negative 2. We've got negative 61250. And then 700 times 175 is 122,500. So if we subtract 61,250 from that, we end up with 61,250. So this is the maximum area that can be created if your width is 175. Now, if it asks for the length, all right, so this is max area. If it asks for the length of it, then we know that L is equal to 700 minus 2W. So to find the length, you would have 700 minus 2 times 175 is 350, and 700 minus that is exactly that. Now again, this is your first, the red is your first answer. That is the width that maximizes the area. Should it ask for the maximum area, that is here. This typically is not a question that they will ask you on this homework set.